This is chapter 15's number 17. A 50-gram object connected to a spring with a force constant of 35 newtons per meter oscillates on a horizontal frictionless surface with an amplitude of 4 centimeters. So part A asks you to find the total energy of the system. So you can use the equation that they give you in the book, which is the total energy is equal to half Ka squared. So since you're given all of these variables already, this is fairly simple. After you fill it in like that, you should get the answer of 0.028 joules. And that's part A. So then part B asks you to find the speed of the object when the position is at 1 centimeter. So in order to do this, you have to write energy total is equal to kinetic energy plus the potential energy. So half Ka squared is equal to half mv squared plus half kx squared, and you have to use this because it's on a spring and it's moving back and forth like this. So then after you rearrange the variables, you should get and then once you fill in all the variables, you should get the answer of 1.0247 meters per second. And don't forget, for this part, when you're filling in x, you should be marking down the part or the point that it's asking you to find. So in this case, for part B, you were asked to find when the position is at 1 centimeter, so you have to convert it into meters and then plug it in for x. So then part C asks you to find the kinetic energy. So total energy is equal to kinetic energy plus potential energy. And in part A, you found that it's totaled at 0.028 joules. Solving for kinetic energy, and you have potential energy is half kx squared. So then you fill in all your variables again. And this is because C asks you to find the kinetic energy when the position is at 3 centimeters. So then for the x, you would be marking 0.03 meters per second, meters. So then part D asks you to find the potential energy when the position is 3 centimeters. And it's basically the same thing as C, except you're finding potential energy instead of the total energy. So you can do this really quickly by writing out. And if you use part C, you know that it's already 0.01225 joules. And so the potential energy should be 0.01575 joules. And that is all the parts for number 17 of chapter 15.